All right, so today I want to teach you about the area formula for trapezoids. Then we're going to learn some special area formulas that you can use for kites and rhombuses, or I guess rhombi. And then we're going to talk about folding those types of problems in with the right triangle stuff we did in Unit 8. So you need to be good with your Pythagorean theorem. You need to be good with your special right triangles, because there's going to be some of that application in finding missing values. First of all, the basics. The area formula for a trapezoid. The area formula for a trapezoid is 1/2 the sum of its two bases. Now, if you remember when we talked about a trapezoid way back in Unit 6, we said a trapezoid is a figure with two parallel lines. Those two parallel lines are considered the bases. So there will be a base 1 and a base 2. And the perpendicular distance between those bases is the height. So here we have a picture of the state of Nevada, and we've got some dimensions, and we've roughly blocked it out to look like a trapezoid. When you get to calculus, trapezoids are pretty important, because one of the ways you start defining the area under a curve is you break it up into minute sections of rectangles, but then you realize breaking it up into minute sections of trapezoids is even more accurate. You'll get that when you start taking your calc class in college, your first calculus class. All right, but trapezoids are important. It's important to know how trapezoids work. So I'm just going to directly plug this information into the formula and see what we get. So I have 1/2 times the base 1 is 205, the base 2 is 511, and then the height is 309. Now it's important to know that we're going to add miles here and then multiply by more miles, so we're going to be square miles in our answer. So that's going to be 1/2 times 205 plus 511 is 716. And you don't have to break it down. You can just put all of that stuff in your calculator. And then 1/2 times 716 times 309 is going to net me 110,622. And remember, that's square miles. So that's just a direct application of the formula. Does anybody have any questions about how this formula is applied? So this formula is on your formula sheet. It's not something you have to memorize. You just have to know where to plug in what. We okay? Any questions? All right. I'm not even going to bother practicing this since that was so easy. I mean, here's the bases, here's the height, plug it in and go. All right. Now, we might have to use some information to find other values so that we can apply this formula. For example, the formula for the area of a trapezoid is 1/2 B1 plus B2, which are the two parallel lines, times the height, which is the perpendicular distance. What am I missing in this figure right here to be able to plug everything into that formula? The height. But if I were to drop a perpendicular line there, I divided this side of the trapezoid up into what? What kind of triangle? What kind of right triangle? Yeah, one of our special right triangles, a 30, 60, 90. And if this whole length of this bottom side of the trapezoid is 7, and this top part of the trapezoid is 5, and this is the height, so it's perpendicular to both of these, then how long do you think this section of the triangle would be? Right. It would be 7 minus 5, which has a value of 2. Because the whole length down here is 7, but if I chop off this much of it, then I'm left with 2. Does that make sense? So I have the shorter leg of a 30, 60, 90 triangle equaling 2. What does that make the longer leg? What do you do to go from shorter leg to longer leg on a 30, 60, 90 triangle?
Long leg equals short leg
Times root 3. So yeah, you would just multiply that by the square root of 3, and you now have the height. So if you don't quite remember those 30, 60, 90 triangle conversions and the 44, 45, 45, 90 triangle formulas, you need to keep reviewing those because we're going to keep using them. Yes, ma'am.
Can you not just do like sine 60 over x is equal to sine 30 over 2?
So that'll work until you have to leave your answer in simplest radical form. And the trigonometry stuff gave us a decimal estimation of the sides, but it didn't give us our answers in
What
like.
if your calculator's like set up to give it?
So yeah, you could set your calculator up to convert that way. It's going to take you a lot longer to do that problem, and it's going to waste time. So if it's a long test, you're going to lose time.
I thought it was easier.
It's easier than just looking at this and saying 2 root 3.
But for like the 30, 60, 90, and like all those are just so many more formulas to memorize.
That's true.
So it like take me a while to remember them.
Supervariant.
You only have to memorize like 2, and then if you want to.
Yeah. I would recommend, based on what I know that's coming ahead, I would recommend you just get very, very familiar with those formulas like you know your multiplication tables, so that they come really quickly. But you're right, mathematically, you can use trigonometry to find that value. All right, so when I plug this in, now it's going to be 1/2 times 5 plus 7 times 2 root 3. And 5 plus 7 is 12, half of 12 is 6, and then 6 times 2 is back to 12. So your final answer in simplest radical form is 12 root 3. Is everybody okay?
No.
Questions? All right. Here's one for you to do. I want you to find the area of this trapezoid, and this is a 45-degree angle right here. So work this out, compare with your partner, and then we'll do it together. Let's see what we did to solve this problem. So I hope you recognize that the length of this part of the triangle right here was 2, because 7 minus 5 leaves you with 2. This is a 45, 45, 90 triangle, so what do you know about the lengths of the two legs? They're both the same, so this would be 2. That works out really nice. So area is equal to 1/2 times B1 plus B2 times H. So in this case, it's 1/2 times 5 plus 7 times 2. The 1/2 and the 2 will cancel each other out, and you'll just be left with an area of 12. And the units there are meters, so that's square meters. Is everybody okay with that?
How much will you, like, if we took a test and say I put 12 meters, but I didn't put 12 meters square, would you just take off 1 point?
Yeah. All right. The other thing, like I told you, is in a rhombus and a kite, we've got this special area formula. This only works for rhombuses and kites, or rhombi and kites. And you can multiply the two diagonals by each other and then multiply it by 1/2. So in this particular example here, the diagonals are really easy to find. First of all, is it a rhombus or a kite? And how do you know? It's a kite because it says, hey, this is a kite. It tells you. And so diagonal 1 is just going to equal to 2 plus 5. And diagonal 2 is going to equal to 3 plus 3.
Is this our formula sheet too?
I don't know. Somebody will have to look and check.
I think it is.
So the area of the kite is going to equal 1/2 times 7 times 6. 7 times 6 is 42. Half of that is 21. Now, that might seem really, really simple because all you got to do is multiply two numbers. Sometimes you might have to use extra information to find out what those two numbers are. Okay, it's not on there. So let's look at this type of situation here where you actually have to do some figuring to find out all your info. So we're talking about a rhombus, and the rhombus is represented by the little diamond things that they draw on the carpool lanes. And we know that the sides of the rhombus are 6.5 feet, And then we know that this length right here is 2.5. Well, if this length is 2.5 and this is a rhombus, what do we know about this other side over here? It's 2.5 because a rhombus is a parallelogram, and in a parallelogram, diagonals bisect. So if we just knew this value right here, we could find this length. Do you see any way, looking at this picture, that we could use some sort of formula to find x? Taylor?
Well, I see why using that upper right corner triangle, you could use those two distances to find the missing link.
Could you use a squared?
And the formula I would use would be the Pythagorean theorem. A squared plus b squared equals c squared. So basically what I'm saying is, since it's a right triangle, x squared plus 2.5 squared equals 6.5 squared. Or, if you wanted to solve it for x is equal to the square root of 6.5 squared minus 2.5 squared. When you put that in the calculator, it comes out really nice. X ends up being 6. So if x is 6, if I can go over here and say, oh wait, x is 6, then what's this length down here? It's also 6. So now, do I have enough information to decide what my two diagonals are? What's my first diagonal? 2.5 plus 2.5, which is 5. What's my second diagonal? 12. So the area is equal to 1/2 times 5 times 12, which is equal to 30, in this case, square feet. Everybody okay with that? Any questions about this? All right. What I want you guys to do is I want you to solve this one. You need to draw it first, label it, figure out what you don't know, and put it into this formula. Area is equal to 1/2 d1 d2. All right. First thing I would do here is I would draw a picture. So I'm going to draw a rhombus. That looks pretty decent. Let me draw the other line over here, and then I'll move that line. That's kind of rhombusy looking. Probably not my best rhombus ever, but it'll certainly do. All right, so here's what you know. You know that all the sides of the rhombus are 10. So I think I'm just going to start out by just labeling 1 and see if I need more later. And then you know that the length of one of the diagonals of the rhombus is 16. But working with this formula, I'm going to need both diagonals. So if I draw the other diagonal, and this whole thing is 16, what's this top part going to be? 8. And what's this bottom part going to be? 8. And that's perpendicular. So from looking at this picture, do you have the way of finding x?
Yes.
What would you use? The Pythagorean theorem. So if you remember your Pythagorean triples, you should know that x is what? 6. If you don't, you can do x squared plus 8 squared equal 10 squared, and x would equal the square root of 10 squared minus 8 squared, which is 100 minus 64, which is 36, and the square root of 36 is 6. Okay, so I now know that x is 6. So if x is 6, what's this side over here?
6.
All right, so what does that make diagonal 1? And what does that make diagonal 2?
16.
Diagonal 2, 16. So now do we have enough information to just plug into the formula? So it's going to be 1/2 times 12 times 16. Half of 12 is 6, and 6 times 16 is 96. So the answer is 96 square centimeters. Is everybody okay with that? All right. There's your homework that you can go ahead and get started on.
Can you leave it out there real quick?
Yep.